Hi everyone, today we are diving into the world of ultrasonic sensors. We will learn how to use the HC-SR04 sensor with the Arduino to measure distance, just like how bats use echolocation. Here's what you will need for the project: an Arduino Uno or Nano, the HC-SR04 sensor, jumper wires, breadboard, and optionally an LED or buzzer. The HC-SR04 is a simple and affordable ultrasonic sensor. It consists of an transmitter and a receiver. There are 4 pins: the power pins VCC and ground, and 2 pins trigger and echo. The trigger is a input pin for the ultrasonic sensor and the echo is a output pin for the ultrasonic sensor. So when we supply a high voltage at the trigger pin, a high voltage is seen at the echo pin also. That is, the ultrasonic sensor gives a high signal at the echo pin. Also, when we supply the high to the trigger pin, the transmitter activates. It sends an ultrasonic wave at around 40,000 kHz, which gets reflected after hitting an object and is received by the receiver. As soon as the receiver receives the ultrasonic wave, the echo pin turns low. As I said earlier, the echo pin was high till now and it turns low. So by using the Arduino, we measure the time the echo pin is high. That is a time taken by the ultrasonic wave to reach the object and come back. Then by using the distance and speed formula, we get the distance. We are going to create 2 variables for the pins of the ultrasonic sensor: the trigger pin and the echo pin. The trigger pin will be an output for the Arduino and the echo pin will be an input for the Arduino. It is opposite in case of the ultrasonic sensor, as the trigger pin is an input for the ultrasonic sensor and echo pin is an output for the ultrasonic sensor. We are also taking count of the temperature for a little bit accuracy. I am using an air conditioned room, so that is why I am using a lower temperature. So first, in setup, we are going to set the pins as input and output respectively. Now we are going to create a function to get the distance from the ultrasonic sensor. First, we are going to turn off the ultrasonic sensor low to turn it off. Then we are going to wait 2 microseconds. And then we will turn the trigger pin high. This will start the transmission of the trigger pin. Then after 10 microseconds, we will turn off the transmitter by writing a low signal to the trigger pin. The reason that we had turned the trigger pin low for 2 microseconds before is for the Arduino to calculate the time interval. We are going to use the pulseIn function to get the time interval for which the echo pin was high. As you can read, Arduino IDE is giving a description of the function pulseIn. Now we are going to check whether the duration we got is correct duration or not within our range. Time cannot be 0. If it is 0, that means the ultrasonic sensor did not work properly or the distance is very small. We are going to calculate the speed using the formula of the known speed and the temperature factor, and then we are going to use the distance formula. Speed equals to distance by time, and the distance is twice, so we are dividing it by half. And for some unit conversion, to get in centimeter, we are going to divide the speed by a factor. Remember that the time we are getting is in microseconds, not in seconds. In loop, we are going to call the function to get the distance, print the distance and wait for half a second and repeat this. And this is how we will get to see whether the ultrasonic sensors work or not. Here is a video where I am testing whether the ultrasonic sensor is working or not. I don't know if you can see the scale properly or not, but I am getting a very good accuracy at around plus minus 1 centimeter. A typical HC-SR04 works accurately from 3 to 4 centimeter to around 200 to 250 centimeter. As for the clip I showed you in the start of the video, here is the code. I just added a LED and a buzzer and then calculated the blink duration and frequency based on the distance. And that is it for today.